Good morning, good evening. Welcome everyone to the next Gen 4 International Forum webinar presentation. Today's presentation on EPRI virtual reality training by Mr. Robert Eller will be presented shortly. Doing the introduction today is Dr. Patricia Pavier. Dr. Pavier is the chair of the Gen 4 International Forum Education and Training Working Group. She's also the National Technical Director of the Molten Salt Reactor Program for the Department of Energy, Office of Nuclear Energy. Patricia.
Thank you very much, Bertha. Good morning, good evening, everyone. It's a pleasure to have Mr. Bob Heller with you today. He's the technical leader too at the Electric Power Research Institute. He currently is the innovation and technology lead for nuclear training, which involves researching, integrating, and implementing applicable technology for training. Mr. Eller has an extensive background in the training world, first as an instructor in the U.S. Navy, then 27 years as a Department of Defense instructor. Later, he became an adjunct professor at Rappahannock Community College, where he taught microcomputer electronics and programmable logic controllers. Before joining EPRI, he was with Dominion Energy at Surrey Power Station, first as an INC instructor, then as a fleet instructional technologist, and finally as an innovation accelerator. During this time, he created a library of over 200 training videos called NukeTube and was the lead on pilot programs for augmented reality, virtual reality, and the use of 360 cameras for training. He was responsible for the research, integration, and implementation of the 21st century classroom upgrades at the Surrey Training Center. So without any delay, I'm going to give you the floor, Bob. I want to thank you for volunteering to give this webinar. I met Bob a few months ago at the CONSI conference, which is the conference on training and education in nuclear. And I saw his presentation. I was really amazed. It was an excellent presentation. That's the reason I decided to give you the opportunity to meet Bob through this webinar. Thank you again, Bob. Thank you very much.
Well, thank you, Patricia, for the invitation. So today we're going to be covering, how we're using virtual reality in nuclear training, or how we can use it, a new paradigm for VR training, and you can kind of go down through the list there and see the others that we're going to be talking about. Now, in this presentation and some of the slides, you're going to see little video clips, and these are actually what the VR training we've developed looks like in there. So without further ado. So traditionally, virtual reality training has consisted of a student going into a virtual environment and performing a task. And you can see a couple of pictures here of where it's been utilized for quite some time. It's been used up to this point in fields that have a very low tolerance for errors. For example, the aviation community, the medical and military communities as well. And as you can imagine, we really don't want anybody making mistakes when they're operating in these fields. If we have any trainers out there, the immersive nature of virtual reality makes it very effective at impacting worker behaviors, which is categorized as Bloom's affective domain. And if, again, we have trainers in the audience, you'll, I'm sure, know that that's one of the hardest areas for an instructor to impact, is the worker behaviors. And the reason for that is we can emulate in the classroom all day long, or the labs, or whatever training environment we're working in, the proper behaviors. But once the worker goes back over into the field, we have no control over that. And the way that VR impacts those behaviors is it tricks the brain into thinking the task is actually being performed. Once you're in there in the virtual environment, and I'll vouch for this firsthand, I can't tell you how many times that I've tried to set my controllers down on a virtual table, then they end up on the floor because you get so immersed in that environment that it just takes over. So how can we use this in nuclear training, or for that matter in any other? Well, different examples here: training on equipment that is too expensive to have at a training center, training on equipment that it would be hazardous to learners or in a hazardous location, training on mission critical equipment that is in use online and you can't take it offline to train on, and training on equipment that has been traditionally a simulation or a discussion only due to the above conditions or other ones. So we've come up with a new paradigm for virtual reality training, and this is one of those slides I was talking about where you can actually see what is going on in the environment. And all of those avatars that you see there are actually real people. The instructor is the filled out avatar you see over in the left top corner there, and the trainee is down in the lower right corner, and the other ghosted avatars are other people that are in the class observing. And the reason we did that is because we found that in some cases, if everybody had the full avatar, like you see the instructor and the trainee in this case, it got too crowded and the view was blocked in a lot of cases. So that was a reason for that. So what's the new cutting edge paradigm here? Well, we can do instructor-led training in a virtual environment. Trainees can join the training from anywhere in the world if Wi-Fi is available. The instructor, trainee, and ghosted trainee observers have full body avatars that are capable of real world gestures and voice communication, and this would be voice communication over the headsets. Videos pertaining to the subject can be uploaded and viewed in the virtual sessions, and management observers can join the sessions from anywhere. They also have, the applications have a self-paced capability. And in that case, it's more like the traditional VR training. The trainee can enter and take the modules at their own pace. Videos that the instructor uploaded can be viewed, and statistics are automatically sent back to the server and retained. And that's true in either case. If we're talking, instructor-led training where we got an entire class in there, or the self-paced, it keeps track of all the scores, the amount of time spent, and so forth. VR, and this is absolutely true, virtual reality is only limited by our imaginations. In some self-paced and instructor-led modules like this one you can see here, 3D models are enlarged to show trainees aspects of materials being covered. And this particular example here is in a cable inspection walk down module. And you can see the terminal strips there. The instructor was up there pointing things out, and the students were observing it. So you can imagine the potential for virtual reality training is, again, really only limited by what we can imagine. Team training. Team training can be done virtually. Here's a demo of a signalman and a crane operator doing a virtual lift. The realistic physics are built in. So in other words, if you were to crash this container that they're going to pick up into another object in there, it will tip and so forth. And basically, we can take the pre-job brief to the next level. This was a demo that was done, and it shows the concept of that possibility. So the hardware that's required is not too expensive. And that is, again, their applications are going to be available in 3D, VR, or 2D PC. They can be used together simultaneously. So that means, you know, if some of the folks in your classes do not have a Quest 2 headset, which is what we're using for the 3D, they can join the class in 2D on a PC. The key point here is up until now, if you were running a 2D application on a PC, it would require an executable file download at the remote end. And of course, these days, that is not something that cybersecurity really likes too much, the folks there. And this particular setup that we've got, we're running WebGL, and therefore it is just streaming from the host server system to a browser. There are no executable file downloads required at the remote end in order to run this thing. There's a companion app for the PC, and you're seeing it right here. You'll notice that we're looking at Willie's first-person view, and now we can change to a third-person view at that bottom button that you see there, and there it is. And if you click and drag with your mouse when you're in a third-person view, you can actually orbit the scene or get any vantage point to kind of better observe what's going on. You can hear everything that's going on. You can see everything that's going on. You can select any person that happens to be in that environment and see either their first-person or third-person view. And the spectator, as it's called, is invisible to all of the people that are in there, so they can't see you. And I think this is a good advantage, because if we're talking about management observers, it tends to not make them nervous. Statistics, as I mentioned earlier, the applications will grade the trainee performance and remediate missed infractions. All statistics are kept on a server, the scores, the time spent, the most missed nodes, and again, you can see some of the examples of what that looks like. They can be viewed by the instructors, local admins that are assigned by the site or company, depending on how they want to set it up. And it'll show how long the students were in there and so forth. A lot of different ways we can display this information on the back-end server. The other thing that'll happen is you'll notice in that top bullet it says it will remediate missed infractions. So when you're done with a node that's in a module, you'll have a choice once you confirm the grades, and that is to either look at the consequences or continue on to the next lesson. If you select the consequences button, what it'll do is it'll actually show the possible consequences of the infractions that you missed. And so that is very valuable. So what we have currently available is an industrial safety module with all the different nodes that you see there. And we're kind of looking at the Open Turbine site right here for foreign material exclusion. But we have an FME counter, which basically you're observing the area monitor counter and trying to pick up infractions of people going in there. Like, for example, one of the bots that are avatars as well, like the one you're looking at right there, has drill bits in the back pocket that don't get checked in, or maybe they're not using the sticky pad properly and showing it to the area monitor, that sort of thing. So you're trying to pick up those type of infractions. The Open Turbine site that you just saw, a couple of cuts of clear plastics in the area. It's a foreign material exclusion area. There's a torn cover over one of the piping units that's in there, things of that nature. Working from heights is another node that's in there. Two people are on a ladder going up a scaffolding at the same time. Lead exposure, they're actually removing some lead paint off of a wall. Confined space, and hot work and electrical safety. And there is a turbine deck free roam also where you can kind of walk around. The electrical safety one in particular is kind of unique in that there are two workers working in a switchgear room, and they're getting ready to rack an energized breaker, which is right next to a de-energized breaker. And so when you're in that environment, you actually go through an arc flash. And I'll tell you, everybody that I have not warned ahead of time that has gone through that module has jumped and said, whoa, or something to that effect when that arc flash occurs. And therein is a prime example of how we can affect worker behaviors. If we can evoke an emotional response, they're going to remember that the next time they go out in the field. There we go. Compression fittings. This was an issue that was happening in the nuclear industry, and IMPO put out a IER on it, and so we decided let's do a compression fitting topic as well. And so you can see the nodes that are within that are, an introduction, how to prepare the tube, the assembly of the compression fitting, and a disassembly, reassembly, and then there's a test on each of those three areas: an assembly test, a disassembly test, and a reassembly test. And you can see on that screen now what it looks like. And just to show you the power of VR, you saw that little tubing piece that was in there that we were working on in that little video clip. I one day just picked it up and looked through it in the virtual environment, and I could actually look through that tube and see that pegboard on the other side of it. That is the amount of detail that's in these things. Corrosion sampler. This one was done for our chemistry folks. It goes through an introduction. It shows how you would go through the filter collection for a corrosion sampler, and then it tests you on it as well. And you can see it here. And they use this in our chemistry training. Tool safety is another one. And you can see the list there in front of you on the screen, and also on the left there: screwdrivers, hacksaws, striking tools, files, power drills, power saws, and pliers. And basically what you are is you're an assistant to the bot there that's working, and you have to determine as they go through each of these nodes, is this a good usable tool or is it defective? So you're inspecting it and deciding what to do with it, whether to hand it to them or not, and dispose of them. Seismic walk down and cable inspection. They've been using the seismic walk down in multiple classes for students all around the world. And then this area right here that we're looking at is the cable inspection that I mentioned earlier, and you have a choice of going through a guided, which is what we're showing here, or an unguided. And this is one of the ones where you are miniaturized down in certain areas of that. Like, for example, if you look to the kind of the lower right area there of that screenshot, you'll see the little magnifying glass, and if you were to click on it when you're in there, that is one of the ones where you're miniaturized down so you can really get a detailed view of what is going on with the problem that's showing. This is our crane demo, which I mentioned earlier, where your crane operator and signalman and material handlers can perform a virtual lift. And you can see the signals being given by the signalman there. This is lab safety, primarily geared toward the chemistry labs. And you can see we have a clean side and a hot side. And You can see one of the infractions there where that guy had gotten squirted in the eyes because he wasn't wearing safety glasses, and he's trying to get over to the eye wash station and trips over a box that wasn't stowed properly. So there's infractions, again, that you would have to point out in either of those two areas of the labs. So the members said, yeah, that crane demo was really cool, but you know, it's not our turbine deck. So what we did this year is came up with a what we're calling a creation lab demo, and you can see, look at that in the background there, you can see that container actually being set in front of you, and what it allows you to do in this case is build out your turbine deck. And you can set it up if you're getting ready to have an outage, for example. You can set it up and decide, okay, this is where we want to place things. This is where we've got to do lifts or lay downs. And once you get it built out the way you want, then you can actually perform a lift, as you see here. So we combined our crane demo with that creation lab. And so the capability would allow you to develop, you know, virtually any environment. If we're talking the nuclear side of the house, you know, the containments, switch yards, turbine decks, pretty much anything you can think of. And we could develop an ever-expanding library of 3D models to place items in these different environments, and basically be able to plug in to this creation lab. Coming soon, we have a steam generator training module being developed, and this is in a containment that's not done. I just wanted to go in there and kind of show what it looks like. But we can take the trainees in there and see the steam generators in the environment, and then the actual training takes place in there as well. And you'll see in a second here a little bit of a shot of what that's looking like right here. And you can see the base plate. And you'll be able to manipulate that 3D object. You can tip it up, look at it, anything you want to do, and it tells you all about the individual parts in the steam generators. So you can see our key takeaways on this. They can be self-paced or multi-person. They're graded and remediated, the trainees. The engagement impacts worker behaviors, Bloom's effective domain. Workers can learn from mistakes without real world impacts. So that's a biggie. And if you think back over your life, when did you learn the most? Well, usually, at least my life has been when I've made mistakes. And I think that holds true for our workers as well. So you can go ahead and basically make a mistake in that virtual environment, and you're not going to have any impacts like you would in the real world. We have the capability for virtual team training and capability to build site-specific environments. Hardware is inexpensive. If we're talking about a Quest 2 headset, they're $399 on Amazon, so pretty cheap. Don't need a high-end computer to drive them. You don't need a dedicated space, like, for example, when you're dealing with a HTC Vive type headset driven by a computer. And that is pretty much it.
Thank you. If you have questions, there's a few questions in the box. If you have questions, go ahead and type those in. And while those are coming in, we'll take a quick look at the upcoming webinar presentations. In October, a presentation on the nuclear workforce of the future, opportunities and needs for the international nuclear sector. In November, a presentation on MOOC, the knowledge management method applied to a Gen 4 project, the continuation of a successful story. And in December, characterization of U-233 for thorium fuel cycle safeguards. I want to highlight the fact that that presentation is presented by Madeline Lockhart. She's a North Carolina State University PhD student. She's the winner of the Pitch Your Research competition that was sponsored by ANS. The first question is there a conflict between workers who want to think on their his or her own versus memorizing instruction manuals? In the thinking process, sorry, let me expand this so I can see it. In thinking process, one examines logically what is the starting point and the end point and figuring out what needs to be done to reach to the end point. In memorizing the instruction manual, no thinking takes place. Assumption is made that the worker does not need to think, but operates in a robotic manner. I don't know if you have any thoughts on that, Bob.
I totally agree with that statement, to be honest with you. And that's, I think one of the advantages to this is it would make people think. I experienced firsthand a situation where we had a Terry turbine, which is an ox feed water pump, at the plant I was at, and there was a 10-year preventive maintenance check, right? That you tear the thing completely apart, you inspect all the parts and pieces, and then you reassemble it, and of course repair anything that needs, repairing. The problem was that all the people that had ever done that particular job or task were retired because, the 10-year interval. So we ended up getting a person down from our sister plant that had done it before. But in the meantime, I was able to put our mechanics that were going to be working with that person into a virtual environment where they were able to, tear apart the turbine, put it back together, just as they would in the real world. And it was interesting because I interviewed them afterwards to see, what they thought. And what they said was there were no surprises, right? There were some bolts in there that had a kind of a weird head on them compared to what you would normally expect. And when they encountered it, they knew it was coming and that sort of thing. But the point is, they had to think outside the box, the normal step-by-step procedure box when they went in there. They didn't take a procedure in with them. They actually just went in and went through the training. I think this encourages that, and it's a lot of situations out there. I'm sure people have seen it. Once they hit a roadblock, there's sometimes a error likely situation where if they just keep on going and don't stop, like we always tell them, that something bad could happen. Whereas, if we get them thinking, then, hey, what am I really doing in here? Without the fear of real world issues, I think that helps it. I don't know if that is answering what your question was or not.
Thank you. The next question is, what more does the VR really offer over and against a 2D PC version? The remote video options with the 2D PC approach appears less invasive as it is just the familiar remote meeting with the instructor being able to run videos without the headset. It also seems the effort to set up configuration for each job to do a pre-job brief could be excessive unless a common repetitive task is being performed, but other routine work does not appear to have a compelling advantage here. What am I missing?
So in some cases, that's probably very true. In others, your immersive, as I mentioned earlier, the immersive nature of virtual reality is key. Again, I have gone to numerous root cause investigations where somebody has screwed up, however whatever might have happened, doesn't matter. And time after time, probably 98.9% of the time, when they're asked, hey, was this a knowledge gap? Was it a training problem? And 98.9% of the ones I've been to, the answer is no. Well, why did you do it? Well, I felt time pressure, or I've done this a million times. That was a big complacency, really. I've done this a million times, I didn't follow step by step, whatever it might have been. that's where I think we get the most bang for our buck with virtual reality training, in that it is going to modify those behaviors. It's definitely been proven in other industries to do that. That's where I see this coming into play. Now, I can tell you, we had a situation where we're replacing a bearing cooling heat exchanger. And what we ended up doing ahead of time was building a mock-up, literally outside, and then I videoed it, and then they showed it to the challenge board of how they were going to do that. So how much time was spent, building that mock-up and then actually running through how they were going to do it, where we could have done it virtually and probably save some money doing that. So there's, uses, and again, one of the things I don't like is technology for technology's sake. There's good ways and bad ways to use this, no doubt about that.
Thank you. Did you use a game engine platform like Unity or Unreal in the development of these training modules? Can you provide training on how to develop similar VR module for in-house projects?
So we used Unity. We actually went to a vendor to do this rather than develop it in-house because they had the expertise. The other thing is some of the capabilities that we wanted to build into this, like, multiplayer, so to speak, where we can take an entire class and upload, videos pertaining to the subject if you want. You don't have to. All of the different scenarios that we got in there, they had the expertise to do it, and in some cases we were breaking new ground. It hadn't been done before. Trying to do this in-house, I think, would be cost prohibitive. Now, we have the ecosystem developed at this point, and it's cheaper now to plug in a module into this ecosystem.
Thank you. That's the questions that I see. Are there more questions for today's presentation? I have one. If the audience will give me a thumbs up, I want to make sure that the participants were able to see the videos and the movements. Was there a lag time? Were you able to see the movements, or were the videos rigid? So if you were able to see the moving parts and the motions, will you give me a thumbs up on your displays? I've never asked the audience to participate like that before, so I'm not sure I'm gonna get any response or not.
Berta, I'm not in the audience, but I could see perfectly.
Thank you. I'm glad to get some feedback.
Yeah.
I have a little screen that shows me how fast it loads for the participants, and the loading from what I could, the timing, it looked very slow. So it looked like perhaps it had ended by the time it got through all the audience views. So I was concerned but I didn't get any feedback during the webinar presentation that things were frozen or anything like that. So I'm assuming that they played and people got to see the 3D motions. Well, again, Bob, I think this is fantastic training material. I can see all kinds of things, in the nuclear industry, criticality, safety training, things like that, just to name a few things that appear theoretical in training that, you could really conceptualize in VR reality. And I think the potential for this is immense, and I'm very excited to see it implemented across the nuclear sector. I think it'll be, very important to the next generation of workforce.
And that's another good point. Berta, and that is that, yeah, you just hit another point, and that is the next generation of workers coming in. And you know, as probably everybody is well aware, it's hard to attract them, it's hard to keep them, and I think this will go quite a ways in solving that as well, because this is what they're expecting, you know,
Yeah.
the high-tech training, that sort of thing.
That's, I don't see a lot of online questions, so, but I really do appreciate your time and your expertise in bringing this. I thoroughly enjoyed it.
Well, thank you. Hope everybody else did too.
I enjoy it too, Bob. It's excellent. And again, all the webinars are archived. So if people cannot watch it, it's available on the gift portal, and it will be available on the Education and Training Working Group YouTube channel. So thank you again, Bob, for your time. We appreciate it.
You're very welcome. Thank you.
Okay. Have a good day, everyone. Thank you, Berta. Bye-bye.